So chapter 11 is our geometry chapter, right? So 11, 4, 5, 6, and 7 are this week, okay? So some more definitions, right? Parallel lines are what 11.4 is on, okay? You guys have this online too, so you can see pictures or see my notes as well, okay? So parallel lines, right? Well, what does that mean, okay? So parallel just means the lines never intersect. Okay, so like the lines on your paper, right? Those would be parallel lines. They're never intersecting, okay? The symbol for parallel lines looks like two L's. So if I say line M is parallel to line N, okay? This is what we use to say parallel. Looks like two parallel lines, okay? So when we have two lines in a plane, they're either going to intersect in one place or they're parallel. Okay, there's no other option. They can't intersect twice, so they intersect once or they are parallel. Okay, then we have something called a transversal. And a transversal is a line that intersects two or more lines. Okay, so then when you have two parallel lines, so here's a line, here's another line, these two are parallel, okay? This would be a transversal. It's one line that's intersecting two other lines, okay? So when this happens, when you have two parallel lines that are intersected by a transversal, we've created special angle pair relationships, okay? And those angle pair relationships are called alternate interior angles. We have alternate exterior. And we have something called corresponding. Okay, so we kind of think about what these words mean, right? These first two, alternate interior or exterior. So alternate means opposite, okay? Interior means inside. So alternate interior angles are going to be inside the parallel lines but on opposite sides of the transversal. Okay, so inside the parallel, opposite sides of the transversal. Alternate exterior, right, means outside the parallel lines, opposite side of the transversal. Okay, and then lastly, corresponding are going to be angles that are in the exact same position. And that means the same position with regards to the parallel line and the transversal. So they're in the same place, okay? We can also see we have vertical angles and supplementary angles, okay, which we already defined. So alternate interior angles are congruent, alternate exterior angles are congruent, and corresponding angles are congruent, meaning if they're an alternate interior pair, they have the same measure. If they're an alternate exterior pair, they have the same measure. If they're corresponding, they have the same measure. Okay? Vertical means they have the same measurement also, And supplementary means you add up to 180, right? Complementary is 90. So those we learned before 11.4. Okay. So let's look at one big example, okay? I have two parallel lines. We're going to say this is line X and line Y. Then you have one line here called line W. And a line here that we're going to say is line Z, okay? And then I labeled a bunch of angles. So we're going to say here is angle 1, 2, 3, and 4, 5, 6, 7, and 8, 9, 10, 11, 12, 13, and then have a box here and says this is angle 14, this is 15, and another box saying that's angle 16. Okay, so just to kind of talk about the definitions, okay? And then we'll go over the measurements here. Corresponding is the same position. So ignoring this line for a second, okay? These two lines are, or actually let's ignore this one, right? These two lines are parallel, okay? So let me just cover that up. This is your transversal, okay? So corresponding is the same, in the same position. So I have these four and these four that I'm relating. So like angle 1 and angle 3 would be corresponding. They're both on top of the transversal or on top of the parallel line to the left of the transversal, okay? Alternate, so meaning on this side and this side now, because this is our transversal. So like angle 1 and angle 5, they're on alternate sides of the transversal, but they are outside your parallel lines. So they're alternate exterior. Angle 2 and angle 6 will be alternate interior because they're on opposite sides of the transversal, but inside your parallel lines. Okay? That's kind of a visual of those definitions. So, then we're going to say that angle 1 equals 120 degrees. Okay? That is the only angle we know. We're going to use that to find every other angle here. So we're going to say this is 120. We also know that Z is perpendicular to X. So that means that this angle 16 would be 90 degrees because it's perpendicular. Okay? So then using what we know, angle 7 is vertical to this, so angle 7 also has to be 120 degrees. Okay? Then corresponding, so the same place. So angle 1 and this angle here, angle 3, are in the same position. So angle 3 has to also be 120 degrees. And then it's vertical here. So this is 120. Okay? Then we know we have angles forming a straight line. So this angle and this angle are supplementary. So angle 8 is going to be 180 minus 120. So this is going to be 60 degrees here. Then this angle is vertical, so angle 2 is 60 degrees. Okay, then we can say that this angle and this angle were alternate interior. So they're the same measurement, so this is also 60 degrees. And then it's vertical here, so this is 60 degrees. Okay, then we're going to do the same thing over here. So this one though, so angle 10 has to be 90 degrees because it's vertical. Okay. Then alternate interior with angle 14. so this is 90 degrees. It's also corresponding with angle 12, so this is 90 degrees. Then the idea of supplementary, right? These two add up to 180, so this has to be 90 degrees. Corresponding to angle 11, this is 90 degrees. Vertical, so this is 90 degrees. And vertical here, so this is 90 degrees. So as long as we have two parallel lines, if you know one angle, right, we start with just this one, we can find all of these angles using our angle pair relationships. So corresponding alternate interior and alternate exterior.